Okay, Cup. So welcome to the third class. That's bad. Not gonna have too much today. Okay, so welcome to the third class of data analytics, where I'm going to be teaching you interactive visualization, probabilistic modeling, and machine learning using Wolfram Mathematica as the platform. Okay, now the first week we had the introduction to data analytics. Hopefully that clarify quite a bit of concept of what it is and it isn't. Okay, there's a lot of words thrown about like big data, data science, and AI and all kind of stuff. So the first lecture was supposed to ground you in the central concept of what it is to have a data-driven analytics. Okay, the gist of it that that should have come at least was among the relationship between all this concept about data science and machine learning and a quantitative model and probability, statistical model and so forth. But the idea is that now we just think of analytics as sort of like a toolbox, right? So analytics is a suite of analytical tools or tools for performing analysis. The form of that tool may be mathematical in nature, mathematical with a lot of probabilistic model in nature. It may be computational. It may be based on artificial neural network. It may be based on machine learning techniques. It may be based on Monte Carlo simulation, all kind of stuff. Large language model, which is a more modern set of tools. But the idea is that anything at all that is going to allow you to make sense of the data. And by making sense of the data, it means that extracting the data for information, and then that information should contain some very important or valuable insights. And it's those insights that would give you strategic or tactical edge to your business, to your enterprise, to your project, to your endeavor in whatever field, okay? And the reason the word data came to the fore, instead of calling it, say, computational analytics or digital analytics, the reason the word data came to prominence, so you call it data analytics, is that all of this is grounded in the truth as evidenced by data. Okay, so you can think of data as the beginning and the end. Okay, it's the beginning because you use the data to build the model. It's also the end because once the model is built, how well it performed is also evaluated against the data. Later on, you'll be very familiar with the idea of data partition, where you have the in sample, out of sample, and to give you a short version of it, the in sample is the data you use to build the model, right? Once you build the model, you use the out sample data or out of sample data to test whether or not that model is good. So in that sense, you can say the data is the beginning and the end of it all. It's the beginning because the in-sample data is used to build the model. It's the end because the out-of-sample data is used to test the performance. And ultimately, real life is data, right? And how you use it in real application, that's data. Okay. So last week, I introduced you to, so that was, the first week was essentially this chapter 1, right? This concept of data. Okay, so we're gonna collapse this, okay? Now, second week, I introduced you to the world, I guess, of Wolfram Mathematica, right? It originally started out in a way as a sort of analytical software for doing analytical mathematics, and I distinguish analytical mathematics from numerical mathematics. For example, e to the pi is something that's symbolically understood, right, as a concept of e raised to the power pi. Now, numerical software would have to interpret e as 2.71 something something, and then pi as 3.14 something something, right? And there's a numerical recipe for raising a to the power b, and you substitute a with 2.71 something something, you substitute b for 3.14 something something, okay? Whereas here, literally, the computer is supposed to understand what you mean by e, what you mean by pi, what you mean by raising exponential. Now, then over time, it becomes a general language that operates more or less similar to functional programming. Okay, again, because this is based on mathematics, right? And mathematics, to be crude, it's also about variable and function. Okay, so if you're gonna do mathematics on a computer, it does make sense that the language follow functional computing or functional programming paradigm. Okay, but having said that, it's also more of a decorative language in the sense that it has that decorative flavor where you don't exactly, some of the function has a lot of implied or default setting, or, usually this is what you mean by performing this kind of function. So you can tell the computer what's your intention. You would like the computer to do some kind of interactive plot, and it's going to try to do that with whatever you are given, whatever you give it, right? So it's a very high level, very high level. And on top of that, then there are tools like a free form language interface. You have the Wolfram Alpha, where you can type in query. And ultimately now I can go to ChatGPT and ask, how would I do something like this in Python? How would I do something like this in Mathematica? And then copy that and try it. If it doesn't work, then I adjust it, so forth, right? Anyway, but the thing that I want you to understand is it's not just a programming language. It's more like an ecosystem, okay? It's sort of like a platform for scientific computation, but a platform is just that. It's a platform. But once you have a platform and people start populating it with library codes, with data, with example data, with curated data, then you have all kind of resource you can draw from. And then you have user group, you have a community chat. All of a sudden become like an ecosystem. Okay, so that's kind of like the general feeling I wanted you to get, that this is kind of much like when you go to like a Python community or Python universe. It's like an ecosystem. Okay, except with Python universe, it's much larger. It's much larger, but at the same time, it is more anything goes, right? Because it's not monolithic. There's no like guarantee that there's a standard way of calling a function. So there are variation depending on what the community or the Pythonista community put in. Okay, so it's kind of very fluid type thing. Whereas Mathematica ecosystem is a lot more rigid. It's a more release like Mathematica 1, 2, 3, 4, 5, and now we're on to Mathematica 14. So it's a bit more rigid. It's more structured, and it has help page and all that. So anyway, but the reason I use it is because, one, it's very high level, right? And two, it has a lot of this interactivity, computational interactivity, visualization that I think would be useful for Basai students who are not necessarily going into the applied digital intelligence, but may go into sustainable development track or health and well-being, working with medical data, genomic, molecular structure, and all that. Okay, right. So last time talk a little bit about, you know, where his mathematics come from and so forth. And I think we got to the 4 types of input, right? So let me start a blank page here, right? So anytime you go to here, by default, anything you do here is a functional or command. If you type in 1 + 1, it's the same thing as calling a function called, okay, well, you get 2, obviously, right? But just to tell you, to show you that what I mean by functional interface, essentially when you type in 1 + 1 and you get 2, implicitly you're calling a function called plus, and you're supplying it with 2 arguments, right? Except the shorthand is this. So even though mathematically, yeah, that's a simple thing, right? But the way of thinking about functional interface is you always communicate with your computer by calling a function an argument. Now, obviously, if you work with just built-in function, then it's a little bit like calculator, where it doesn't matter how many functions you have, it's just a finite set, okay? Calculator has add, subtract, multiply, divide, maybe exponential. So that's 5 buttons, right? Built-in Mathematica may have maybe upward of 5,000 built-in function. Still, that is a built-in function. So it does something, one thing, right? Well, it's not programming if you don't sort of like customize it. So if you take the built-in function, piece them together, then it becomes a computer program. And if that snippet of computer program is used a lot by yourself, you're not going to keep writing this over and over, right? So you're going to encapsulate this and define this as a function, except it's your own user-defined function, right? And then you can use this in a larger piece of code, which in turn can be wrapped together into a function and so forth. So you can see why you can keep on building complexity upon complexity upon complexity, okay? And that's what a computational platform is all about. It's not just doing a simple calculation, it's building computational complexity from the ingredients, right? So with that, let's go back to, now anyone remember exactly where we left off? So let's tell you what, I'm gonna do this. I'm just gonna go to the entire cell, right? So this is the entire kernel. The most outer is chapter 2. So I'm gonna shift enter. And what it does is it calculates everything, computes everything in that chapter, okay? And I put a little sound at the end, so we should hear, eh. I think it's supposed to be a violin sound. Anyways, all this is done. Okay. Okay. Oh, it does use online service. Some of this I created, I haven't signed in, never mind, I don't need that. Okay, so yeah, remember I told you about this creative thing where you can sort of like prototype your program, right? And if you want to show it to your client in the pitching, instead of having a screenshot, you put this on a cloud, right? And then just pass around your HTML. Okay, but you need to sign in obviously, because otherwise you wouldn't have the cloud space. This one failed because I haven't signed in the cloud space in this laptop. Okay, I kind of forgot to keyword. Anyway, okay, right. So let's get to the meat of today. So far, you guys okay, right? And we agree that that's the sort of thing we cover in the first 2 weeks, right? Okay. Now we go to the particular programming language, and I started a little bit already on that, right? So I start with well, what's the most important primitive? It's assignment. I think we went over that, so I'm not going to go over that again. I'm just going to collapse it here. Okay, assignment is when you say x is equal to 5, right? X is equal to 5. So from now on, Mathematica, until you close the session, thinks x is always 5. Fine, that's an assignment, okay? And just to, oops. Okay, so what's the difference between this? X equal to 5. So x is equal to 5. That's an assignment. X equal to 5 That's what? That's a Boolean operator, right? Checking whether or not it's equal, okay? So I think that was not very exciting, okay? This is just my last class. So that's an assignment. One equality sign is assignment. Two equality sign is not an assignment. It's checking whether or not it's a mathematical expression of equality, right? So is it true? Yes. If we give it to 6, no, it's false, right? Okay. And so 5 is equal to 6, no. 5 is equal to 5 dot. Now, technically, in some language, I don't know if some of you grew up with C language, 5 and 5.0 are not the same thing. But here, it mathematically is understood to, you probably meant that. So it's not, in computer science speak, it's called not strongly typed. Okay, so 5 and 5.0 are considered the same thing. Whereas in C programming language, you can have a floating point, you can have a Boolean, you could have integer and all that. Okay. So that was, now, the whole point of doing things on a computer is you want to do it on a bunch of things, right? So that's where list comes in. List is a way of storing. Okay, list is a way of storing. So this is a list. A, blue, and hello. Okay, oops. Elephant. Okay, a blue elephant, right? It's just a way of storing things so that if you, this is my this is my storage. I store this. And I want the second element. Okay, get that, right? This is just storing thing in the list so that you can fetch it by position. It's nothing more than cataloging. This is not that interesting yet, okay? So list is a universal, okay, this applies to every single language on earth, right? Computer language. Doesn't matter, Python, mathematics, C++, C, Java. At some point, you're gonna have a list. Okay, it's the most fundamental, guys. It's the most fundamental data structure. In fact, it doesn't have any structure aside from the fact that it is an ordered list. Ordered set of objects. Okay, fine. Well, the important thing about this, okay, is that from our point of view, we are going to be dealing with data. And what is about data? Do you guys remember that? Data is a sample of measurement or records, right? That is abstract from the population so that you can do some analysis on it and make some conclusion or insight about the population from which you extract the data, right? So if I take your height and I record it as 20 values and I use it as a basis for inferring how tall Chulalongkorn University students are, then your heights are my data, right? Well, long gone is the day where data are small, data are big. In fact, we used to have this term called big data. This term is going to disappear soon. You know why? Not because data are getting smaller, because virtually all data are big now. Yeah, it's going to get to the point where there's no point distinguish between big and not so big data. I think that's the spirit. We're not quite there yet, by the way, but I just want to tell you that at some point you're going to take for granted that when you work with data, you're going to be working with big data in some definition, okay? Whether or not it's because it has a lot of volume, big, massive volume of data, because it comes to you fast, like a live information feed, right? So velocity, or whether or not it's a variety of data. So not just number, but text and words and pictures and all kind of stuff. Okay, fine. But at the minimum, data is about multiple copies of something, right? So instead of having this kind of like a blue elephant, chances are it's going to be something like X1, X2, X3. So it's going to look like, you know, say something like, okay, I'm just going to type this. Some data point and Okay, let's put this. Okay, don't worry, you can type along with me, but you get to know. So basically, some data point, the first one, the second one, the third one, the fourth one, the fifth one, the sixth one, right? Right. Now, let's say you can type along so you get some intuition of what we're working with. So it is a list, but it's not a list of arbitrary objects so that I'm just storing the first element, second element. It's essentially similar kind of things so that I can do mathematical, analytical, probability, statistic function to the first one the same way I can do it to the second one, to the third one, right? Now, let me just show you. So for example, this is my, let's make it a little bit small. So let's call it X, okay? Oops, sorry. I forgot X is 5 now, so I have to clear X, okay? So now X is a generic number, okay? X. Yeah. So now this thing here, okay? This thing here, if I want to do something like exponential, I can do this, right? I can do exponential x1, exponential x2. So you can type in, but it may not make sense to you now why I'm using this command, but exp/at, right? What it does is, again, the whole point of a list is a list of similar things. So what you can do to the first guy, you can do to the second guy. You can do to the third guy. In this case, what I want to do is take exponential of the first guy, second guy, third guy, fourth guy, fifth guy. Right? So does that make sense now that we go list is going to be useful? Okay. Again, if I'm going to ask you a conceptual question on the exam or midterm, what are lists good for? Number one, storing things. So you can access it by position. 2, you can keep, right, items that you can apply similar operation to, and you can just repeat for the whole list. Okay. So here's a list of students. I say hello to the first guy, hello to the second guy, hello to the third guy, right? If it's a student, comma, elephant, comma, refrigerator, it makes no sense for me to say hello to a refrigerator. Okay. Likewise here, because x1, x2, x3 are kind of like some numbers, right? I can take exponential to the first one, second, third one. So that's why concept of list is a primitive, number 2. Yeah. And we did that. This is, I hope this looks like a review of like the last half an hour of last class, right? Finally, again, function. This is the name of the game, guys. The whole thing is about function, okay? The whole thing is about function. And then last week I went to the difference between a prompt, univariate function. A prompt is a function that doesn't have any argument. You can't supply it with anything like tomorrow. Okay, you don't need to add any information, right? Tomorrow is tomorrow. Okay, so now, tomorrow is one of those things. A command is a little bit like a function that doesn't require anything, but you know, it has 0, but sometimes you can add some information to it. Anyway, univariate function, it takes 1 argument, right? Multivariate function, it takes more than 1 argument. Okay. Now, here, and now I want you to start typing along, right? I think we stopped kind of here, I think. Am I right? Anybody? I think we kind of stopped here last time. Anyway, I'm just gonna, that's how I remember, okay? So anyway, so this is univariate function. It's a function that takes on only 1 value, okay? So exponential, you can do that, right? You can't put in many numbers, okay? Dimension is like gives the up. It's not a mathematical function, but it's sort of like a housekeeping function. It's say how many rows, how many columns. So if I define this thing earlier, did I define this earlier? I didn't. So if I define this RGB, if I define this object somewhere else, okay. Did I define it here somewhere? Tell you what, let me shift enter these two things just to make sure that I have got everything. Okay, so now RGB is defined. So the dimension of RGB is 2 by 3. Why? Anybody? What's RGB? I define this object as a list of lists, right? A list of two things. The first thing is just the letters. The second thing is colors, okay? So this is a list of two things, each of which has three things. So the dimension of this guy is 2 by 3, okay? No surprise there, okay? No surprise there, okay? Now, if I say RGB is equal to, okay, and then I add something like A, B, C, okay? And then I ask the same question. It's gonna say, well, it's 3 by 3, right? 3 by 3. Okay. So it's a 3 row of 3 column. Now, watch this. What happened if I didn't give it the right number of argument? I just did this. Okay. Certainly you can do that, right? List of 3 things. The first 2 has 3 things. The second thing has 1. Now, this is not a full-fledged matrix. So when I apply the word dimension, it doesn't say anything about the second, right? It only says it has 3 rows. How many columns? I don't say. I'm not going to say anything. Why? Because sometimes it's 3, sometimes it's 1. Okay. Let's go back to the original. So it kind of makes sense, right? All this is very intuitive in some way. Okay, so that's just a function. Okay. Here's a function that's built in. It's a little bit, I like this number. Okay. Now this number happens to be product of some number, right? Some prime and not prime. So I can factor integer. Okay. And there it said it has 2 3 times. So 2 to the power of 3. So that's 8. And 41 1 time and 89. So if you take 41 times 89 times 8, you should get the original number, right? So this is something that's very high level because behind this, there's a lot of mathematics in it, right? So there's a lot of algorithm in there. That's why I said, whereas a calculator has 5 built-in buttons, Mathematica has maybe 5,000 built-in buttons. So this is one button. This button called factor integer. Now, what if you give it a number that cannot factor? Okay. For example, let's make the last number 1. It turns out this thing is a prime number. You cannot factor a prime number. It doesn't break down. So it is 29,199 to the power 1. Okay. If I put in 3, obviously this is going to factor out, right? So this is a lot of fun. Okay, so let's go back to original. Okay, fine. So that's function. Okay. Now ignore this thing. Ignore this thing because this is a it's complex function. But just look at this. Outside here, there's only one function, traditional form. Outside here, there's only one function. So when I did this, it gives you 2 things: traditional form and input form. Okay, this is what traditional form looks like. So it gives you a format, right? You have seen this in high school, correct? This is an integration function, right? Integrate. Okay. Now, okay. So input, blah, blah, blah. Okay. Now here's the thing. Sometimes you have univariate input. Okay. Now this is very tricky. If you have a univariate input, okay, is it possible that you could put in 2 numbers? Sometimes yes, Because instead of inputting a number, you input a list of numbers. Okay. In that case, even though the function only take one thing, implicitly it knows that that thing is a list of things. Does that make sense to you guys? Okay. It's still considered univariate function from this point of view. And I hope you don't get confused. Okay. If I give you X and Y, right? And I want to compute X squared plus Y squared. Okay. What kind of function is this? It's a bivariate function, right? Right? It's a bivariate function. Come on. X and Y, right? X squared plus Y squared, right? That gives you like a square of a radius of X and Y from maybe a unit circle, right? So X squared plus Y squared is some kind of radius function. It takes two variables, okay? Now, I can do this. I can define a univariate function that takes one thing. Univariate means one variable, but I interpret that variable as a list. So give me one thing. You would give me open bracket X, comma, Y, close bracket. It has two numbers, but you gave me one thing. Okay. So if I expect a list, that's still called a univariate function. So I can define my function in two ways. I can define my function as take one thing, interpret it as a list. For each element of the list, square it and add everything together. Or I can say it's a multivariate function. It's a bivariate function if I take the first input, X, the second input, Y. So two variant, right? Please don't look confused now because it's going to get really bad quick. Okay. So you understand, right? Programmatically, I can do two things for the same result. Okay. Give me two things. I'm going to square the first. I'm going to add square of the second. Or give me one thing. I interpret that thing as a list. I take the first element of that list, square it. I add the square of the second element. Exact same number come out. Okay. But programmatically, the first one is a univariate function. Second one is a bivariate function. Okay. What difference does it make? When you call a function, you have open bracket, one thing, or open bracket X, comma, Y. Right? Okay. So in this case, norm is one of those things. Okay. This is also, okay. This is also. Oops. Now, I want you to type along with me because this makes sense. Okay. This here is a univariate function. It takes one thing. That thing happened to be a list. Okay. However, if I did this, this is a what? This is a multivariate function. It takes 7 arguments. Right? I don't know. It only expects one thing. So this total thing doesn't work. Right? Okay. Now, of course, you can do something else like sum or something like that. Right. So again, just because you have a whole bunch, 3 number, 4 number, that doesn't mean that it's a multivariate. It's a single thing. It's the same thing, right? Now, this table is a this kind of scripty table is a function that I create myself for formatting. Okay, so this is not part of standard mathematical language. That's why I gave you the header file that has a blue thing. You shift enter that, it has this. Okay. Oh, Speaking of which, I haven't done it myself. So see, it doesn't know what table is. So I have to go here. Sorry. There, this is a header function. I define it right here. Okay, now this function should work. Let's go back. Okay, so we have this thing called table. By the way, I promise you that this lecture today is going to be fairly dry, but after you get through today, it should hopefully get more fun. Okay. I've tried in the past to sort of like start introducing data analytics and introduce a function later as we go along. It could be more fun to do it that way, but in the end, it's very difficult. So I decided, okay, let's do this. Let's just go through the painful process of learning the primitives. Okay. And once you go through the primitive, then we can start playing. So let me, where do we go? Go back, go back, go back, go back, go back, go back, go back. Wow. Okay, there it is. Okay. So now it knows the functions of shift enter, right? So you can see that this here, various objects that I, show. Okay. So now, because matrix is a more mathematical thing, sometimes you would put it in matrix form. So this is kind of matrix form. Okay. You guys know this, right? A row vector is not the same thing as a column vector. It's a column vector transpose. You know that, right? Okay. Right. So these are just dimensions of matrix. Again, you have to have a full matrix. If it's a 3 by 2, it's 3 by 2. If it's 3 row of maybe 2 columns, 3 columns, then it's not a full matrix. Okay, so those are the problems. So these are all function. Okay, these are function. Don't worry about getting all this, because when you get the book, right? So you follow through. So all these are not only introduction to univariate function. These are functions that you will be using all the time. Okay, so instead of just giving you arbitrary, well, factor integer is something you don't use all the time, but that's just a one-off example. Grid is something you can use all the time, table, all kind of stuff. Anyway, so univariate function, okay? Now in Mathematica, univariate function, sometimes mathematicians don't like it. For example, computing a factorial, okay? I can do this, factorial, factorial, yeah, factorial of 5. I get that, right? But mathematician knows 5 and exclamation mark should be the same thing. So as much as possible, Mathematica will try to respect the mathematical form notation. Okay, that's all I'm trying to say. Same thing as here, right? I can type in exp7, and it's the same thing. Oops. It's the same thing as e to the 7, right? But mathematician is going to prefer this. This is nothing, okay? Now, exclamation mark to the back is factorial. Exclamation mark to the front is logical negation. You done that in logic class? If I say 1 is equal to 1, that's true. Okay, but if I put a factorial in exclamation mark in front of it, it's not, then it becomes false. Okay, so this is kind of a fun little thing. Okay, anybody knows what a gamma function is? Well, don't have to. Well, a gamma is like a very powerful function in mathematics. It's sort of like saying factorial of 5 is equal to 5 times 3, 4 times 3 times 2 times 1, right? What's factorial of 5.5? You can't. You can't. So gamma is kind of like an interpolation of factorial. Okay. Anyway, I'm just giving you this. So the formula is gamma of 1 plus x is equal to x factorial when x is an integer. But when x is not an integer, the gamma function is going to fill it in. Huh? Why am I telling you this? Okay, because I love mathematics, but two, because in next chapter, you're going to have this thing called gamma distribution. It's going to use gamma. Okay, but anyway, just ignore it for now. Okay, univariate, you can do composition, obviously, f of x, g of f of x, right? Exponential of log of a should be equal to a, right? Because exponential and log are the opposite. So this is all true, right? Exponential of log, log of exponential. Okay, fine. Now, this is something you see a lot. So if I have a function in Mathematica, okay, I have a function f of x, then I have g of x, then I have h of x, okay? Can I do that? Obviously, right? But you know, with this bracket, too many bracket is going to look ugly. So they give for one univariate function, the shorthand for it is to say, let's just apply. So f apply to x, and then g apply to f, then h apply to x. Okay, this is just shorthand. Okay, try it. So for example, if I want to say exponential 5, okay, I can also say exponential apply to 5. Right? So what's log of exponential of 5? 5. Gets back. Right? Okay, just type in along just for fun. No big deal. Okay. Now, so that's using a prefix. It's called prefix syntax. Okay. Likewise, you can do what's called a postfix syntax. That's like saying, give me an x, give me an x, send it to exponential function, and send it to logarithmic function. Okay. Well, it's going to get back x, right? So x exponential log. Now it doesn't simplify in this case. So let's see. Okay. So sometimes you see this a lot. This is called postfix. Okay, that's all I want to give you right now. Not that you need it, not that you need it, but sometimes you will see that in a forum. Okay, you know how people who write Python codes for many years, they have like shorthand, and when they talk about it in the user forum, they would express in shorthand, you know, so that, you know, it's, I guess it's shorthand. It's a bit like that here. Okay. So 123 and log and all kind of stuff. So this is not very interesting. Okay, that's as much I want to say about univariate function. It's a function that takes one thing. That one thing may be a list. So that one thing doesn't have to be one number. Okay. In fact, you will see that a lot of built-in function does image processing. So you do something like highlight one thing, and that one thing is a picture. And as I told you, picture is what? Picture has how many numbers? It has 512 times 1024 times 3 number, right? It's a tensor. So many number, but you call it one thing. Okay. So that's called univariate function. Now let's go to multivariate function. Okay. Multivariate function, okay, takes two value, two argument. Technically, minus is a bivariate function, right? Exponential is a univariate function, exponential 5. But 5 plus 7, how many variable do you use? How many argument do you supply? 5 and 7, right? So addition means nothing. For univariate case, it is a bivariate function. So addition, that's why in mathematics it's called binary operation. Okay, it's bivariate function. Okay, now, okay, so you will notice that these are, I wrote as an example here, okay. You will notice that what's common to all of this is a text, but it shows that the function is over here, okay. You will see that I have an open bracket, I have a closed bracket, and there's a comma between the first argument and the second argument. So all these are bivariate function, guys. Okay, it's expecting two things. Most of the time, this is because the two things are doing different things, right? Again, a list is good because it can store a bunch of things, but you can apply the similar operation. Okay, so usually when you use this, you send it as a list. Okay, do the same thing to everyone. But if you send two things and it has special function that you cannot switch place. For example, A plus B. It's very important that you use A first and then B later, right? Can you switch a row of B plus A? Yes, you can. How about minus? Not so fast, right? Okay, so A plus B, fine. B plus A, nobody, you don't mind. But subtraction, yes. Division, yes. Right? Okay. So the first one and the second one has different role. Logarithm to a different base. Integrate. So this is a good function. This is a function called integrate x squared with respect to x. Anybody knows what that function is? Well, it's antiderivative, right? So it's x n plus 1 divided by n plus 1. So it's this. Okay. Now, there are a lot of built-in function in Mathematica that ends with a Q. What it means is that it's a query, it's a question. Is it true? Is it true that B is a member of ABC? Yes. Is it true that AB is a set of ABC? Right? Now, let me do this. Let's go to a separate thing so I don't clutter this. Oops. Okay. Okay. Is this a univariate function or multivariate function? It is multi because it's two. This is the first argument. It's called a reference set. The second argument is called the query, right? And how would you know that? How would you know that? Okay. Imagine you have a list of inventory stuff. So this is a set of inventory that you have, and you want to see if this is your client. Your client wants to know, okay, do I have this stuff in stock, basically? Okay, except this is, 1,000 items long, so you can't see. You can eyeball this, right? AB is inside of this, right? It's a subset of this, okay? But if you have like 5,000 items in your department store, and you are trying to be a supply chain to another mom and pop store, right? And they want 200 items, and you want to check if the 200 items that your mom and pop customer want is part of your 5,000 item inventory, right? You guys know this, right? This is common thing, okay? Do we have this? Do we have A and B in our collection? Okay, so that's called a subset, right? Now, let's say you didn't know this. You didn't know this, okay? Okay, so I have a set set A, okay, inventory is equal to A, B, C, okay? And then the shopping list is equal to A and C, let's say, okay, A, B, C, D, E, F, okay? Let's say this is what you got, right? I'm going to define this. Okay, so now it's black. Now let's say you don't know what this is, so you don't see it. You don't see it. I put semicolon again so it doesn't show. Okay, so now you want to know if something is a subset of the other. And this is the first time you're using Mathematica. How would you do it? Well, two things. If you can't think of it, it's so complicated. You don't know what the word subset is. You think something that's part of something. You can't think of the word subset. What do? You go to ChatGPT. What is a technical term for when a collection of something can be found in another collection of something else, right? ChatGPT is going to say, oh, it's called subset. Okay. Then next question. How do you compute subset in Mathematica? ChatGPT is going to give you that answer. But let's say you don't have ChatGPT. You happen to know that this operation requires something called subset, right? You just type in subset, S-U-B, and see if it autocorrects. See, there's an autocorrect, right? Oh, there's a subset and there's a, let's say I type in subset Q, okay? So it's a query, again, you know that Q has to do with a query, but now you don't know how to use it. So what do? You type in F1. Now I had this problem before where my keyboard is set up so that my F1 doesn't work like an F1. Hold on. I think, oops. Okay. In my keyboard, I have to type in FN, but you know, can you guys do that? Type in subset Q and then just type F1. Does it take you to this page? Who doesn't? Okay, let's go to this page. Just not, okay? Okay, so now it tells you how to use it. Again, if a univariate function is kind of obvious, right? There's only one thing, but now you have two things that they're doing different job. Okay, so subset Q, list 1 and 2. It yields true if list 1 is a subset of list 2 is a set of list 1. So obviously the first one is the reference. That's it. So how you do that? You would say, oh, okay, the reference is my inventory and shopping list is my query. True. Yes. Right? That makes sense. Okay. Now, if somebody comes in and my customer wants to say X and Y and Z, okay? Oops. It's going to return false because it's not part of your inventory. Okay. So a whole bunch of this is very simple. By the way, I encourage you to play with this because this kind of manipulation of set of data, it doesn't matter what language. If you go to Python, you're going to do the same thing. They'll use a different word, but same technique, right? Database programming is all about checking subset, if you ask me. Anybody knows what database programming is? Like Oracle? Well, database is a huge storage of data. And you don't want to get the whole thing. Think of storage of data as an inventory. And think of database query as getting item. Except instead of getting pots and pans and banana and orange, you're getting data item. Okay? So it's all about, you know, checking the inventory and fetching stuff. Okay? So this kind of thing. To get something, it has to be in there. Okay. Okay. Fine. So let's go back to here. Okay, so multivariate function, okay? So we got this multivariate function. Okay, this is just a fun thing. Basically, okay, now this is something that you are going to use, okay? This is very important. And this is an integration function, okay? Now, I'm just gonna do something here. Integrate, okay? Again, your mind has gone blank. You remember that in calculus, area under the curve, you want to do something like that, you go to ChatGPT. What's the mathematical name for computing area under the curve? ChatGPT is going to say, oh, integrate. So you come to mathematics, integrate. Oh, there's an autocomplete. So integrate is a built-in function. You go to F1. Integrate. Integrate has this. Gives the indefinite integral of f dx. So you have to have f and you have to have x. It's obvious, right? Well, another version of it is definite integral. That means you're not just doing finding antiderivative, you're substituting the limit point, right? The end point. So x min, x max. What if you want multiple integral? There it is. Okay. And you can even do this. This one is a bit fancy. Okay. Over a region. Okay. But certainly these three are from your high school. Correct? So I'm going to say, I'm going to integrate, let's say x square. Now, how do I square out that? Oops. Sorry. Yeah, you guys know how to do this? Control upper triangle. So, okay. So I want to integrate, say, x to the power 5, okay? With respect to x. That's obvious, right? That's x to the 6 divided by 6, right? But if I want it to be a definite, I have to put the second thing, not just x, but a list of things. Now, this happened to be a list of things where not all things are doing the same job. It's actually doing different job. This one is A, this one is B. So stare at this for a moment. This is a function. This is the variable, except I put bracket around it. So I say, don't just integrate indefinitely, integrate definitely with the limit A and B. Okay, so let's see what's the difference. So the first one is this guy. Okay, right? Now, instead of doing this, I substitute B and then substitute A and I take the difference. It's going to look like this. Right? So that's B to the 6 divided by 6 minus. Okay. So here, look, and this is very specific, guys. It's saying, I want two things, two different jobs. The first thing is a function. The second thing is an argument. But for the argument, you have the option. You can put in just x, in which case it's going to interpret it as indefinite because that's all it can do. But if you want a limit, give me the limit. Okay. If you want a numerical limit, 1.2 and then 3.4, then it's going to give you a number. Correct? All right. So if you now, here's the thing. How about from 1 to infinity? Can you do that? Escape I infinity. Escape basically goes to this palette, special character, right? But I know how to do escape, infinity. Okay. It happens to be 0.12. Now, obviously, this thing converges. If it doesn't divert, if it goes to infinite, it's going to give you this. Does not converge, obviously, right? So to the 5, it doesn't converge because it blows up. Okay, fine. So now you have function in 2. Most of the function then, okay, and this is what it's going to be for the rest of your I can say this is more like specific to Mathematica, but in other language, it's some variation of this. For example, in object-oriented C++, sometimes you can supply different length of argument. So the sum function knows that if you don't supply with an argument, it goes for the default, for example. Okay, it's that kind of thing. Well, with Mathematica, then the way to find out what kind of options you have is basically to go to F1, go to the help page. And that help page is going to give you the variation. Yes, you can give no argument, or you can give 1 argument, or you can give 2 argument, or 2 argument, but the second one is a list. You know, something like this is specific. And when you write your own, build your own function, user-defined function, you are going to have your own specification as well. Okay, so this is something that comes with user page. In Python, you would go to like a help page, and there'll be the list of the function and would say some parameters, right? Okay. Same thing here. Okay. Now, multivariate function. Okay. This one here, when you get the notebook, the book, I encourage you to follow the example and do understand. And you come to me if you don't understand. But forget this infix. It's a little bit too much. Okay. Right. Multivariate function. So what's the opposite of integration? Differentiation, right? Right. So likewise, you can do this. Okay. Literally, now I'm just making a nice format here, but the function is right here. For example, derivative of, let me make it bigger. Derivative of x cubed y to the 5th with respect to x and y. What's that? That's partial ones with respect to x, partial ones with respect to y. That gives you this thing. Okay, so the left-hand side, maybe I should give this in a, yeah, well, you see it in the book when it comes, okay? So this is printed in the book. So the left side, this is the command, that's the right side. Notice, okay, let's go to the last one. This one is fairly fancy, right? What does it say? The first one is always a function. D is a built-in function for derivative. It's used so much that it doesn't, it's just D. It's not derivative or take derivative, it's just D. D of x cubed y 5th. Now, notice this. Instead of putting x, I put x bracket 3. What do you think that means? Common sense, guys. It's a partial derivative with respect to x 3 times. Right? You can do that, right? Mathematically. So here you can do anything. Okay, so this is basically take derivative of this thing with respect to x 3 times. Obviously, x cubed, when you take derivative with it 3 times, you're going to get a constant. Y to the fifth, you take derivative with it once, you're still going to get y4. Right? So it's very simple. So multivariate function. Now, this is another good one. Again, these are example of multivariate function, 1, 2, 3. But this one can use one function as well. Sorry, one argument. This function is a shorthand for saying create a list of number. 1, 2, 3, 4, 5, 6, 7, 8, 9, up to, but not above this. So if I give you a range of 1 to 0.34, it's going to give you a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay? So that's a univariate function, right? Well, actually, it's deceptive. This is actually a multivariate function, except what? This is the full version. The version takes three arguments. From what number to what number in step of this increment. So generate a list that starts from 1.23, ends at or before 12.34 in step of 0.45. Okay. Now the reason I want to go this explore in depth is because of this. See how this one is kind of like a default version of this. In other words, if I didn't say anything, Mathematica assume you start with 1. If I didn't say anything, Mathematica assume you increment in 1. Right? So range, in other words, range 1.12.34 is the same thing as range start from 1 and at 12.34 in step of 1. Same thing, exact same thing. Okay. Now, this looks trivial, guys. This looks trivial. But this is what makes Mathematica very friendly for developer. Because when you build data analytics, you are going to have a lot of parameters to play with. Okay, think of this as not just 3 numbers, but 8 numbers. Okay, build a neural network that takes so many configuration, right? How many layers, what types of layers, how far, how do you test? It has so many specifications, let's put it this way. Okay, but common sense, okay? Common sense say, hey, if I'm going to generate a list of number, if I didn't say from where to start, I should start with 1. If I didn't say what increment is, let's make increment 1. So you can see why this is a functional programming, right? It tells you a function. This is more like decorative programming. It's saying that, you know, if I didn't say anything, you just guess what I want. Can you guys make that mental leap between this line and that line? This is very rigid functional programming. It says, tell me what to do with what specification. Start from 1, finish no higher than 12.34, step in increment of 1. Okay, but let's say you don't feel like specifying all this. You just say range 1, 2, 3, 4. This is more of a decorative flavor. It's not decorative programming, it's still functional programming. But this is what I mean by decorative flavor. If you don't specify, sometimes it allows you to skip the details. By default, this is 1. Okay. By the way, in Python, how would you write something like this? You would say something like from equal to 1 to, yeah. So you actually name the input. You can do that as well. Okay. So that language has that. But in this case, I think this is a lot easier for me to work with, okay? Same here. Now imagine in the future, in fact, not very far near future, probably like 2 lectures down, I'm going to say something like build a neural network with my data. But in fact, what I mean is build neural network with this data and standard architecture and standard number of layers. So you see what I mean? So building a neural network takes a lot of configuration, like designing a car. You don't just have one number, right? You have 1,000 numbers that defines what a car is, the length, the height, the horsepower, all kind of stuff, right? That's functional. That's giving you all the specification. But if you are in a decorative mood, I just want for you to buy me a car, right? The decorative sense is that you declare what you want. I want a car. Don't bother with me. Don't bother me with details, right? And your friend, your boyfriend, your girlfriend buys you a Toyota because that's a very generic way of buying a car. Okay. Now, if you say buy me a car, make sure it has 4-wheel drive. Okay. Then it's more specific, right? But that's still generic Toyota with 4-wheel drive. Okay. It's only when you specify, buy me a car with this brand, with this make, with this model, with this color, that you get a complete specification, right? So this is what I mean. Okay. So this function here is very instructive. This way. See? Now, of course, and this is you don't have to just read through this, but you can certainly see the mathematical notation, partial derivative, and all that. In fact, in my note, sometimes I don't use the word integrate. I do this. So this thing here is the same thing as this. Now, this is just for math nerd, maybe. Okay. So yeah, this is the function. Definite integral from here to there, right? So you get some number. Okay. But if I write this in a notebook or technical white paper for a software that I'm trying to pitch to my client, this looks amateurish. So I'm going to write it like this. Okay. Gets the same thing. Okay. So as much as it can, Mathematica, even though it's a functional programming language, it tried to respect that a lot of people using it are good in math. Okay. Same, but you know, this is just different. Same thing with this kind of input, right? The root, the kind of stuff. Okay. Modular function, you guys know what this is? Clock arithmetic, that's very important. You wouldn't have cryptography, you wouldn't have Bitcoin, you wouldn't have encryption, you wouldn't have any of those if you didn't have this function. Okay. Now, some function is literally decorative. In other words, it doesn't produce anything. It says what your intention is. Does that make any sense? A function, you give it something, it gives you output, right? It's a function. You give x, it gives y equal to f of x. Okay. Well, this is where you go in full decorative mode. If I write this function, normal distribution, open bracket, let's say 1, 2, and 3. Okay. Right. What does it give you? Nothing. It gives you nothing. Why? Because this doesn't work like a functional programming. Because as far as the computer is concerned, you are just declaring your intention. My intention is to work with a normal distribution. Okay. Now we can do something else. Okay. And Okay, let's do it. Let's do it. Let's say, okay, I want a normal distribution with mean 0 and standard deviation 1. Okay, this is my intention. It's my intention. Okay, shift enter, nothing happens. Because all I said is that, hey, pay attention to me. I'm talking about normal distribution, okay? But I haven't asked it for anything. Now, if I ask for the probability distribution function, PDF, right? You guys know what a PDF looks, right? So now I want PDF of this guy. PDF, okay? Again, you don't know how to this work. So let's go to Shift F1. PDF. Give me, it's a bivariate function. It gives you, it asks for distribution and the random variate X. Okay. If it's multivariate, then it's got more than one X. Okay, fine. So if I give this, it does, okay. Now, PDF of, again, give it the name of the distribution. In this case, hey, I'm talking about normal distribution. Okay. And with mean, let's make it mean something. Mean of 1 and standard deviation of 0.2. Okay, let's do that. Okay. -5. Okay, let's do that. PDF of this. Now, PDF expect 2 variable, right? Okay. Yeah, sorry, I'm going to take a break real quick, but okay. So the second one is X. Okay. So now, good. Shift enter. There it is. It becomes a function. This function takes two variables. The first one is a mean. The second one is standard deviation. But it doesn't do anything. It's only when I use it as a name of a distribution to supply to the PDF, and I do this. Right? So this is a function. Okay, I want you to type this because well, you see. Okay, so let's do this. Let's do it one step at a time. So decorative, nothing. Call it a function, PDF, fine. Okay, now watch this. I have another function called plot. Okay, plot. This plot function also looks like an integrate function. In other words, it expects 2 things. If you don't believe me, go to F1. Expect 2 things. This has the same kind of similar format like integrate, right? Give me the function and the variable and give the limit. Now, plotting function has to have finite limit. Otherwise, it's not, there's no such thing as an abstract plot. So there's no indefinite version of this. So let's do this. So let's plot all of above, comma, X between say -8 and 2. Okay. And let's copy this. There it is. That's a little bit too far. Let's 6. Okay. Oops. See? Right? This is a function that expects 2 things. Give me a function, of X, give me the range of X. X go from -6 to -4. And what's the function? Well, that function is a PDF. but the PDF is generic function. You have to name it. Okay, so if I give you a different function, okay, if I give you sort of let's say a uniform, oops. Okay, it gets a different function, right? Same structure from -6 to -4. It's a PDF, but now I call a different thing. So that's the decorative part. Hey, I want you to work with uniform distribution. Okay, so let's go back to normal distribution. Now, normal distribution and okay, let's go back. Right? So now, basically, you have the three main primitives. Now, before we take a break, I'll give you one more example of a function which is useful because table is so ubiquitous. Remember that the table data, right? You can generate a list of number using the function called literally table. Okay, so table here, there it is. Okay, now what it says is, okay, let's go to F2. Table creates something and this specifies the number of copies. Okay, well, let's go back. Let's go back to blank screen. Table. Okay, table of the word cat, comma, 5. What do you think is going to happen? It's just going to generate a list of 5 cats. Right? Is that interesting? No, because they're all identical cat. Okay. What if I want my cat to have different color? Okay. What if I want a cat to have a different name? Now let's do this. Let's say cat control minus. Remember, control this goes up, control minus go down. I. Okay, you did 5 cat already, right? So now instead of 5, I put I, comma 5. Now it's cat 1 to cat 5. So table is kind of the flip side because it generates a list, right? So let's see how far we need. Okay. This is a very nice table, by the way. You guys know what a Pascal triangle is? Right? It's a table, blah, blah, blah. Array is also a table. Okay. I'm going to stop here and take a quick break. Okay. So now, again, what are the 3 primitives that you need to know? Well, you can't work with things unless you have an object, right? So you have to name something. So that's an assignment. Just to create things to work with. You can't go wrong with that, right? So assignment. Particularly assignment, it is a function, but I haven't mentioned the word function yet, right? The first primitive is assignment. X is equal to 5. That's an assignment. What's the second primitive? List. Because list is ubiquitous. Doesn't matter what language, Python, Java, you're going to be working with lists. Finally, if you're working with functional programming, you're going to need to work with function. So function. So these are the three things, right? Three things that you need to know as a baseline concept. It's the hello, it's like alphabet of the English language. It's the hello, how are you? That sort of thing, right? So you need to know assignment, you need to know a list, how to work with it, and how to get members of a list, access individual member, and then you need to know function. And the function so far is built-in function. And I've shown you two versions of a function that's strictly speaking, well, I've shown you function that doesn't take argument, function that cannot take argument, function that takes 0 argument, function that takes 1 argument, function that takes 2 argument, and then you can have function that takes more argument, right? However, it's defined. Once you get to 2, 3, 4, 5, we call it multivariate, okay? But occasionally, if it's just 2, we use the word bivariate. Just get used to that. Okay. In that function, I introduce some of the more useful ones, such as table, right? That's very useful one. Member list, member query, all kind of stuff. But anyway, there are 5,000 more. So I can't cover them all. Okay. And finally, the last one that I show is a function that literally creates a list. Okay. So it's a create a list iteration. This is something that if you are from a Python background, you would see in the term of, anybody? List comprehension? Anyone? No? Have you heard of that? List comprehension is in Python, right? Like I for I equal to table of I for I. It's called list comprehension, no? Yeah. I think the technical term for it is list comprehension. Okay. So create a table of cat subscript I for I equal to 5 to 1 to 5. That's what this did. Okay. Okay. Let's take a 5-minute break.